In a few minutes talking about reciprocal functions and graphing, specifically graphing reciprocal functions over the next 3 or 4 videos. And one of the things that we have to concern ourselves with, kind of like with rational functions, is do we have any restrictions on the domain? Are there things where the domain is going to become undefined? And so before we look at these two specific examples on determining the limitations on the domain, let's take just a moment and think about a reciprocal function. So the parent function of a reciprocal function is f of x equals 1 over x. And the type of graph we're going to have is a hyperbola. The domain and the range are going to be all non-zero real numbers, with the exception of we're going to have asymptotes, both horizontal and vertical, and specifically on our vertical asymptote, that's going to be determined where any value of x that would cause our domain to go to 0. And so in the parent form, that would be x equals 0. And we're going to have a horizontal asymptote where f of x, or y, equals 0. And we're not going to have any intercepts. And these graphs are going to be in 2 pieces. It's going to have 2 parts to it. But we'll get into a little bit more of that in the next video. We'll look at the graph of a couple of reciprocal functions. Then we'll talk about transformations. But here we're just going to be looking at what is the limitation on the domain. What can x not equal in this particular function right here, where we see that f of x is equal to 2 over, or divided by, x minus 1. And to determine that limitation on the domain, we're going to set our denominator equal to 0 and solve. So we got x minus 1 equals 0. X is equal to 1. And so therefore, our limitation on our domain is that x cannot equal 1. Or actually, I should say, even though that is what x cannot equal, our limitation on our domain is actually that x equals 1. Because when x equals 1, if I substitute 1 in here for x, I got 1 minus 1, which of course is equal to 0. And we're going to be undefined at that point. So we got a reciprocal function, 1 over x. We might also see that with we'll talk about transformations in another couple of videos. So horizontal asymptotes, vertical asymptotes, this is where the value of x and y cannot equal something. But again, we're looking here at this moment at just limitations on the domain. Let's look at one more. Now, in this case, we got f of x equals 7 over 3x minus 2. And again, to determine the limitation on the domain, we're going to set that denominator equal to 0. So we got 3x plus 2 equals 0. Let's subtract 2 from both sides of our function. We're going to isolate our variable. We got 3x equals negative 2. And we're going to divide by 3 such that our limitation on our domain is where x equals negative 2 over 3, or negative 2/3. And so again, think about it, if we were to substitute negative 2/3 into our denominator, so I say we got 7 over 3 times negative 2/3 for x plus 2. Well, when we distribute this or multiply the 3 times the negative 2/3, the 3's cancel, we end up with negative 2 plus 2 in the denominator, or 0 in the denominator, and that is our limitation. X cannot equal negative 2/3, or the point at which we're going to have this vertical asymptote is where x equals negative 2/3. That's going to create a vertical asymptote at that point. Now in our next example we're going to look at, we'll take a look at the graph of a couple of reciprocal functions and discuss, again, our vertical and horizontal asymptotes. We'll actually be able to see them, and then we'll look at it algebraically as well.